Hello everyone! In this video I want to talk about saturated models in structural equation modeling and confirmatory factor analysis. In case you're new to this channel, on this channel I present weekly statistics tutorials, often related to structural equation modeling and other latent variable models, and also often related to the Mplus software. If this is something that interests you, then please subscribe to this channel, and if you like this video, then please hit the like button. In my work as a statistician, I often get questions about saturated models in structural equation modeling and confirmatory factor analysis, and it's something that is very confusing for many people who are novel to structural equation modeling because they don't know what to do with a saturated model, what exactly it means, how to interpret fit statistics, whether they can make use of the parameter estimates, and so on. So in this video I want to clarify some of these issues based on a simple example and also based on the output from the Mplus software for a structural equation model that is saturated. So as an example, I'm going to use this simple one-factor model with 3 indicators where we estimate the factor loadings freely for 2 out of the 3 indicators, and that is an example of a saturated model. So I want to go through this and first of all explain why this model is saturated and what this means, and then we're going to take a quick look at the Mplus output to see what is special about a saturated model in terms of the fit statistics and other output. So here you can see on the left-hand side a path diagram of a single factor model. You can see the first indicator y1 has a loading fixed to 1 for identification, to identify the metric of the latent factor. The other 2 loadings are freely estimated and indicated here as lambda 2 and lambda 3. And then also we have measurement error variables epsilon 1 through epsilon 3, for which we estimate variances, the error variances, and then also we estimate a factor variance. Now, why is a model like this saturated, or we also say just identified? The reason is that in this model we are estimating as many parameters as we have pieces of information from our data. So we're basically using up all the information in our observed data to estimate model parameters, and therefore this model is just identified. It's so it just works to estimate all the parameters, but the model does not reduce any of the information in our data. And so to understand this better, let's take a look at what parameters are estimated in this model. So first of all, we're estimating the 2 loadings, lambda 2 and lambda 3. We're also estimating the variance of the factor f, so that's 3 parameters. And then we have the 3 error variances as well for epsilon 1 through epsilon 3. So now we are at 6 parameters. And then in addition, we estimate also 3 intercepts or additive constants for the observed variables. So in total, this model has 9 free parameters. Again, 2 factor loadings, the factor variance, the 3 error variances, and 3 additive constants, or we say intercepts. Now let's take a look at our observed data and let's see what the information is that can be used to estimate those parameters. And so here you can see the observed variable means at the top, and then the covariance matrix at the bottom. And that's all the information that we can use to estimate parameters. And so you can see we have, obviously with 3 indicators, y1, y2, y3, 3 means in our empirical data. And we have 3 variances, which you can see here in the diagonal of the covariance matrix. And then in addition, we have also 3 covariances, so the relationships between those 3 variables. And so those are the 9 pieces of information that we can use to estimate parameters from: 3 means, 3 variances, 3 covariances. Obviously, with more variables, you'd have more information because there would be a whole lot more covariances. But with 3 variables, we only have 9 pieces of information, and this model estimates 9 free parameters, and therefore it is saturated. It uses up all the data. And that implies that here we're not putting any constraints on our observed data. So for example, this model does not put any restrictions on the means. It doesn't assume that the means need to be equal, for example, or it doesn't assume that the covariances need to be equal or the variances. So there are no restrictions. All of the information that we have in the data is just perfectly reproduced. All the means, all the variances, all the covariances are perfectly reproduced, and therefore the model doesn't reduce the information that we have. Now let's take a look at the output for this model in Mplus. So first of all, the input file, which you can see here. So that's the exact example, 3 indicators, 1 factor. We can specify this model in Mplus with a single line of code in the model statement that says f measured by y1 through y3. Mplus will automatically fix the first factor loading to 1 for identification. It'll by default estimate the factor variance and the remaining 2 loadings, as well as the 3 error variances and the 3 intercepts for the variables without us having to say anything. And then in addition, we can ask for the sample statistics, so we can take a look at the means and covariances like we've already done for the observed data, as well as we can look at residual output, which indicates the model implied means and covariances, as well as residuals, meaning the difference between the observed and model estimated statistics. So let's take a look at the output for this model in Mplus. And so one thing that you can see when you go to the fit statistics is that the chi-square test of model fit for this model here is 0, has a value of 0 and 0 degrees of freedom. And that is something that many people find confusing, because what does this mean? Does this mean the model is invalid? Does this mean I can't interpret the model? Does this mean the model fits perfectly? What does this mean? So what it does mean is that the model by default, so to say, or trivially, fits perfectly because it reproduces all the observed means and covariances and variances 100%. There are no restrictions in the model, and therefore the model could never not fit. The only way that this model would fail, so to say, is if you had variables that weren't correlated, where all the covariances were 0. In that case, the factor variance wouldn't be identifiable. Or if you had variables with where some are negatively correlated, then you might have some convergence issues, perhaps because the program would expect those variables all to be positively correlated. But other than that, really the model can't really fail. If you have any covariances that are not 0, then this model is identified and will fit perfectly, so say trivially. And so you can see that from the fact that there are 0 degrees of freedom, because 9 parameters minus 9 pieces of information is exactly 0. So there's nothing left over here, no testable constraints or testable restrictions. And therefore also the chi-square value is 0, because there's no discrepancy between the observed mean vector and the model implied mean vector, or between the observed covariance matrix and the model implied covariance matrix. Now, another way that you can see this is by looking at the residual output in Mplus, where you get the estimated means that are implied by the model or reproduced by the model. If you compare those to the observed means that are given under sample statistics, then you'll find that those are exactly identical. And you can also see this by looking at the residuals, which are all 0, because the residuals give the difference between the observed means and the model implied means. And so all those means, these residuals for the means are 0, because there's no restriction on the means, and the means are just perfectly reproduced in terms of the intercepts in this model. You can see this when you scroll up and you take a look at your intercepts here. You can see here you find the means. They could just go directly into those intercepts. And the same is true for the covariances. When you take a look at the model estimated covariances, you'll find that these are exactly identical for a saturated model to the observed covariance matrix. And again, you can also verify this by looking at the residual covariance matrix down here, where you can see that all the elements in that residual covariance matrix are 0. Now, is this a problem per se, that this model just uses all the information and doesn't reduce the information in any way, it's not necessarily a problem, because if your only interest is in the parameter estimate, so for example, if you only care about estimating the factor loadings, perhaps the standardized factor loadings, looking at the reliabilities of the indicators in terms of the squared standardized factor loadings, looking at residual variances and so on, then you may not care that this is a saturated model, because you might find the information useful enough, or you might find that this is all you want. You want to just simply determine how reliable those variables are as measures of your factor. However, a saturated model cannot really be falsified, because this model will always fit. So the fit statistics basically are meaningless for a model like this, because it cannot be rejected. It must always produce a chi-square of 0, indicating perfect fit. So for a model to be testable, it has to be more than 0, has to have more than 0 degrees of freedom, and then it contains testable restrictions, and then you can also falsify the models by means of the chi-square test and potentially other fit statistics. So in summary, saturated models are not necessarily bad, they're not necessarily useless. If your only interest is in the parameter estimates and testing certain parameters or looking at them, then that's totally fine. We have other examples in statistics where we routinely use saturated models. For example, in multiple regression analysis, a multiple regression model is always saturated because it uses all the information to estimate regression parameters, and that's the same issue as here, and we don't care that it's saturated. We still look at R squared, we still look at the parameter estimates, the regression coefficients, and in the same way we can also do this in factor analysis and structural equation modeling. I hope you found this video useful. If you did, then please subscribe to this channel and hit the like button, and I'll see you next time.